Hello guys, what you can see here is the CLion with open CMake repository, the regular CMake, with integrated CMakeSL language. So now we are going to install the binaries. They are going to be installed here, so let's install them. And then in the binary folder we have three binaries from the CMake repository, which is CMake, CPack, and CTest, and the CMakeSL binary, index binary, and complete binary from the CMakeSL repository. So what we are going to do is we are going to use the CMake binary that supports executing CMakeSL language to build the repository of CMakeSL. So let's clone the repository here. And see what we got there. So we have cloned it here. Let's open code here and see what we got. So first of all, on daily basis I use the CMake, of course, to build CMakeSL, and as you expected, and there are a couple of CMake lists, a bunch of CMake lists to handle that. We have the root CMake lists. In the source we have the CMake list that adds up directory for every library and stuff like that. We have CMake list for examples, for tools also, and one special CMake list which is located in the external project, which is googletest. The googletest is used, of course, for testing, and it has its own CMake lists here. But besides the CMake lists, the old CMake lists, we have also a couple of CMake lists that CMSL, which are implemented in the CMakeSL, of course. And so here is the root CMakeSL. We are building the libraries in CMakeSL also as well. Here we add subdirectories for every library, and for example in AST we have okay, so let's see what we got here. We are importing module. This module is very simple. It has only it exports only a couple of variables with the directories. All variables are in the CMSL namespace. So in the AST library we import this module, and then we have the main. When the execution starts, we have sources. Okay, so as you can see, the Clang format is like working out of the box with one with the CMakeSL code with one like issue, because I implemented the importing in the way that there is no semicolon needed at the end, which is an issue, because I will fix that. And because of that, the Clang format like fails formatting the next line, but that is something that we can live with. So we have sources as a list of some strings, of course. Here we add to the project library called AST with the sources. We add some directories to the include path. In this case, the CMSL source directory, which we imported from this module. We include it with the private visibility, and then we find in the project another library called Lexer, and we link the AST library to the Lexer using public visibility. And for other libraries we have like the same stuff. So we have sources, we are linking something, adding include paths, and so on. So let's see what we have in the root CMake. We import the same directories, the same module. We have a regular CMake minimum required. We set some C++ standard, which is for CMakeSL requires C++ 17, so we set that. Here we are setting some old-fashioned variables to the CMake, let's say, engine. So these variables are going to be visible in the scripts that are written in the old CMakes. So yeah, as you can, we use CMake set old style variable, the variable name and the variable value, and it is done that because the tests, CMake list, the tests are not implemented in the CMakeSL. Which means for tests and for all like test binaries, we have old CMakes which are implemented in CMakeList.txt, and these CMakes require like these CMakes use some of these variables, so we have to define them properly. But we are going to we will be back to test later. Then we create some projects. We add subdirectory that creates all of the libraries, and then we have we are handling three options. Options for tools. The CMake option type is it is used to handle the option that you are familiar with, because you can set an option, for example, in from the command line to trigger something or to turn off something, and the CMakeSL handles that as well. So if the CMakeSL with tools option is on, we add subdirectory tools, which creates some other libraries and the CMakeSL binary. And then here is a typo, and here is a typo too. Okay, so let's fix it right away. So we check another option, CMakeSL with examples, and we create examples. Like we add subdirectory for examples, and the last one is CMakeSL with tests. And here some fancy stuff is going on, because if you use CMake and if you write tests in your project, you probably know that you probably want to enable C-test, enable test and include the C-test module of CMake. And the CMake enable C-test does exactly that things. And next we add subdirectory with the external Google test project, and add subdirectory with the test. And here's the fancy thing, because as you know, because I mentioned that the external Google test and the test subdirectories don't contain CMakeSL scripts, which means that you can add subdirectory that contain like part of your project handled by the old CMake scripts. So this is huge. I mean, you can, if you would like to, if you have a project in the and this project is used in CMake, uses CMake at least, you can refactor this project to the CMakeSL part by part, subdirectory by subdirectory, not the whole thing at once, and that is pretty handy, I think. And in fact, the CMake lists for Google tests are not so trivial, so I'm very happy that this just works. Yeah. Let's look at this for a while. No, I'm just kidding. So yeah, that's pretty much it for the CMakeSL root. Now let's go back to the folder with cloned repository. Let's create build directory. Let's go there and let's use the binary, the installed binary with the CMakeSL support. We want to build the CMakeSL. We don't ask about this. CMakeSL compiler. I got clank 7. And here let's pass the options that I talked about for tools, project examples, and tests. So CMakeSL with tools, CMakeSL with examples, and CMakeSL with tests. And let's go. Here is some print that I forgot to remove, but yeah. Anyway, it's not perfect, of course, because it's not perfect yet, because CMake is warning us about not used options. That is because they are not used in the old CMake's lists and scripts. They are used only in the CMakeSL. So, but we are fine. We have make files here. So let's just build everything. It will take a while. Yeah, here you can see some building CC files from the Google test, so we can see that it works. Here is the Python script is generating some code. Yeah. I'm very sorry for the microphone quality, but it is bad. If I'm going to record more videos, I'm probably going to buy some better mic. So yeah, I encourage you to check the description. In the description there is a link to an article, the broader article about changes that has been done in the CMakeSL since last post on Reddit. And of course, I encourage you to contribute. The project seems complex, but it actually is pretty easy. And I am here to help. No worries. Just clone the repo, make some fun changes, and create a pull request on GitHub to master. Waiting. We can see that it is building currently the tests binaries. It builds it already. Now it builds the CMakeSL binary. Yeah. A little more. That's the biggest one. Binary for test, SEMA test, SEMA or SEMA test. And done. So yeah. Now let's, for example, to make sure that tests are built, let's make test. It runs all the tests. Cool, that works. We can also make install which is going to install the old binaries, but like I said, this CMakeSL is not perfect yet, so it will install also the binaries from googletest, the stuff from googletest. Yeah, but why not? So we are in build. Let's go here. We have installed here. So let's go to install the bin. We have CMakeSL binary, so yeah, just for fun, let's create a hello world. Hello CMakeSL world. Let's return something and okay. We have it here, yes. Cool. So yeah, that's pretty much it. Again, sorry for the microphone, but I just wanted to post this video. You can lower the voice, so it will probably help. Once again, I encourage you to check the article. See ya.